All right, happy calculus students. Going to do my first implicit differentiation. I wrote the words at the top. Sometimes what we've been doing is explicit differentiation. The y has always been already by itself, but now we're going to do implicit differentiation. Now, it's a little weird, so I'm going to do some examples. You should look at the examples in section 3.7 of your book. I'm going to do a few examples, and I'll attach some CUDA software worksheets for you to practice also, but you really need to do this. This is the last thing that I'll do before our test next week, so you need to get on doing these things so that you don't fall behind. All right, so implicit differentiation. It's really not that bad, but it's kind of weird. So here we go. All right, so we don't do anything, we don't solve for anything, we just start differentiating. So I take the derivative of x to the third, and that's pretty straightforward. That's 3x squared. All right, now what we do is with the y to the third, we're going to call that 3y squared, but because it's a y, we have to include the dy dx. Okay, so that's where it starts to get kind of weird. So with y to the third, I brought that 3 down and then made it y squared like normal, but then because it's a y, I have to do dy dx. All right, so now on the right side, this 18xy is really a product. Okay, it's going to be, I'm going to call this 18x, and then the second one is going to be y. So we're going to do the first, which is 18x, times the derivative of the second. The derivative of y is just dy dx, plus the second, which is y, times the derivative of the first, which is just 18. So on the right side here, I've got 18 twice. I'm going to go ahead and bring that out in front. And then I have x dy dx plus y. I'm not going to do that. I changed my mind. Sorry. I'm not going to do that because that's way too messy. So 18x dy dx plus 18y. And then on this other side, I still have the 3x squared. I'll write a little bit smaller. 3x squared plus 3y squared dy dx. All right, so now what we have to do is get the dy dx on the same side. So we're solving for dy dx. So what I'm going to do is I'm going to subtract 18x dy dx from both sides, and I'm going to subtract 3x squared from both sides because I want to get the dy dx together. All right, so then this is gone over here. So I have 3y squared my dy dx minus 18x dy dx equals 18y minus 3x squared. By the way, you should be writing this down as I do it to make sure it makes sense, and then pausing it every time I get going faster than you are. All right, so now, oh, and now I'm crooked. So now I want to, I guess I can't do that. So now what I want to do is factor out a dy dx. So dy dx, I'm going to factor that out so I get it all by its lonesome. And I have 3y squared minus 18x equals, this side over here doesn't change, 18y minus 3x squared. All right, and now to solve for dy dx, I have to divide both sides by 3y squared minus 18x, divide 3y squared minus 18x. So dy dx is equal to that crazy fraction, 18y minus 3x over 3y squared minus 18x. Notice when you do implicit differentiation, you have x's and y's in your answer. Now, the only thing I can do to simplify here is I notice everybody can be divided by 3. So that's what I'm going to do. I have dy dx is equal to 18y divided by 3 is 6y, minus 3x divided by 3 is just x, over the 3y squared divided by 3 is y squared, minus that divided by 3 is just 6x. And that's it. That's my dy dx by implicit differentiation. So it's kind of weird, but it's not that bad. It's a lot of algebra. Okay? So here we go. I'm going to do lots of algebra here again. So 3xy plus 7, the quantity squared, is equal to 6y. So I can't really solve for y. So I'm going to do my implicit differentiation. So I'm going to bring this 2 out in front, like I always do. So it's 2 parentheses 3xy plus 7, and that'll be to the first power. And now I have to take the derivative of the inside. Well, the first thing I notice is I have this, which is a product. So I'm going to think of this as 3x times y. So the derivative of a product is the first, which is 3x, times the derivative of the second. The derivative of y is just dy dx, plus the second, which is y, times the derivative of the first, which is just a 3, plus, and that's it for that guy. And now I take the derivative of 7. Well, the derivative of 7 is just 0, equals, now I take the derivative of 6y, which is 6 dy dx. Pretty awesome, right? That's pretty exciting. Okay, so now let's, the first thing I notice is I got this 2 hanging out in front and it's being multiplied. So I'm going to divide both sides by 2 to get rid of some of the numbers. Okay, so I'm going to divide this by 2, so this then is going to become a 3. All right, so now I'm going to do some multiplying because I got dy dx hiding inside this parenthesis. The only way to get it out is to do some distributing. So the first thing I'm going to do, though, is kind of clean it up a little bit. So I have 3xy plus 7. The exponent of 1 doesn't matter, so I'm just going to write parentheses 3x dy dx plus 3y. Plus 0 is silly. Equals 3 dy dx. All right, now the next thing I'm going to do is do my foiling fun. I'm going to multiply, multiply, multiply. So here we go. I have 3xy times 3x dy dx makes 9x squared y dy dx plus 3xy times 3y makes 9xy squared plus 7 times 3x dy dx makes 21x dy dx plus 7 times 3y makes 21y equals 3 dy dx. All right, so now I look at this and I notice every single term can be divided by 3. So I'm going to go ahead and do that. And let me fix this. This is dy dx. I'm going to put this term next to this term because those are the ones that have dy dx. Actually, I'm going to subtract those and put them on this side so that all the dy dx's Are on the right side. Okay, 1, 2, 3. So divide everybody by 3 first. So I get 3x squared y dy dx plus 3xy squared plus 7x dy dx plus 7y equals dy dx. All right, so I'm going to subtract these. Again, I'm going to subtract this one and put them on the other side so that all of my dy dx's are on the same side. So I'm going to subtract, oops, I'm going to subtract 3x squared y dy dx, and I'm going to subtract 7x dy dx, and I'm going to subtract it from this side over here, minus, what was that? 3x squared y, 3x squared y dy dx, and I'm going to subtract 7x dy dx. Okay, notice it's algebra fun. So on the right side, the left side, all I have left is 3x y squared plus 7y. And on the left side, I have dy dx minus 3x squared y dy dx minus 7x dy dx. Okay, so now I'm going to factor out that dy dx, and I'm left with 1 minus 3x squared y minus 7x. And this left side is the same, 3x y squared plus 7y. And now I'm going to divide by this mess here, 1 minus 3x squared y minus 7x. I'm going to divide by 1 minus 3x squared y minus 7x. So my final answer of dy dx is equal to 3xy squared plus 7y all over 1 minus 3x squared minus 7x. And I can't do anything with that. It's as simplified as it gets. So there you go. All right, so those are 2 examples. I'm going to find some easier ones or some ones that have the answers, or you can do some of the odd ones in section 3.7, but you need to start practicing. Please send me a note in Teams saying that you've watched some of these videos. Thanks. Bye.